Hi everyone, this is Mrs. J, and today we're going to learn about parabolas. Before we get started with that, I have a quick warm-up for you guys, so please pause the video and give this a try on your own, and hit play when you're ready to check. Alright, go ahead and check your answer here. So remember, I like to move any constant to the other side of the equation before I complete the square, and then please make sure you factored out the 3 before you do your completing the square formula. So if our b value is 4 over 3, the number that completes our square is 4 over 9. So you take your b value, you divide it by 2, and then you square that. But we're really adding 4 over 3 to each side because 3 times 4 divided by 9. So make sure you're adding 4/3 to the other side of your equation. And then to factor this, remember the number in your factor is always going to be half of b when you're completing the square. And then this should be your final vertex form. So today we're going to learn about a more technical definition of a parabola, and we're going to learn about some new characteristics of parabola. So by definition, a parabola is a set of points that is equidistant from a line, which we call the directrix, and a point, which we call the focus. So we have a few extra things here. Before, when we graphed parabolas, it was just the actual parabola, but now we're really going to focus on this line and this point, so again called the directrix and the focus. So here's what they look like. So here's your parabola. The focus is a point that is always going to be on your axis of symmetry. So if you have a vertical parabola like this, your focus is always going to be above or below your vertex, and it's always going to be inside your parabola. So if you have an upward facing parabola, it's going to be above it, like it's inside the parabola, and if you have a downward facing parabola, it's going to be below. And then your directrix is going to be outside your graph, and when you have an upward facing parabola, it's going to be a horizontal line. So here you can see what the focus and directrix look like. So if you're looking at that definition again, the parabola is any set of points. So any point on your parabola should be equidistant from the directrix and the focus. So you can see this point, if you find this perpendicular distance and this distance, they should be the same. Take any point, this distance and this distance should be the same. Again, that should be true for any point that is on your parabola. Those two distances should be the same. So that's the technical definition of a parabola. And you can actually also have a horizontal facing parabola. So it's no longer a function. Here we're not really concerned with functions. We're looking more at just the parabola. So if you have a horizontal parabola, your focus is actually going to be to the right or left of your vertex. So here's our vertex right here. I'll call it or I'll draw a little arrow. Again, this is our vertex, and this is our focus right here. So you can see that it's to the right of our vertex, and it's still inside our parabola, but again, it's always going to be on that axis of symmetry. So if you have a horizontal parabola, your axis of symmetry is going to be a horizontal line. And then you can see here that our directrix is actually a vertical line. So it's always on the outside of our parabola, but again, this time it's a vertical line. So vertical parabolas have horizontal directrix, and horizontal parabolas have a vertical directrix. And again, your focus should always be kind of within your parabola. So today we're going to learn a new standard form of parabolas that will allow us to find that focus and the directrix, whether it is a vertical parabola or a horizontal parabola. Okay, so now we're going to talk about those equations for our parabolas. So here we have a vertical and a horizontal parabola, all the information you need to know. For both of them, I want to point out that our vertex can be found at HK. And then you'll see this new variable, this p value. So the absolute value of p is the distance from your vertex to your focus or your vertex to the directrix. It's the same, the absolute value of p should be the same for either to the vertex, the focus, or the vertex to the directrix. So this p value is going to be really key to helping us figure out where our focus and directrix are. So how can you tell, first of all, if your graph is going to be vertical or horizontal? It depends on what variable is being squared. So if x is being squared, it's going to be a vertical parabola. And if y is the term being squared, it's going to be a horizontal parabola. So you might have something that looks like this, or you might have something that looks like this. Again, these are just rough sketches. So for both of these, our vertex can be found at h, k. So I want you guys to notice that h is always grouped with x, whether it's the term being squared or not. And k is always the number grouped with y, again, whether it's squared or not. And I also want you to notice that for both h and k, there's that negative in front, implying that whatever you see in the equation, the vertex is actually at the opposite. So it's at, if this is minus h, it's actually at positive h, and same for minus k, it's actually at positive k. So the standard form, you have x minus h squared equals 4p, so you would want to factor out any coefficient here, and then y minus k. And notice this says 4p, so you can take whatever the value is here, set it equal to 4p, and that allows you to solve for p. So for this, in this case, since we have an upward facing parabola, our focus would be somewhere above, so this would be our focus. And our directrix would be a vertical line, or a horizontal line somewhere below. So this is our directrix. And this distance is p, is the absolute value of p, and this distance is also the absolute value of p. So it's either the distance from your vertex up to your focus or your vertex down to your directrix. And then over here, again, our focus always falls kind of within our parabola, so maybe it's like right here. So again, this is our focus. And then our directrix for this one will be a vertical line on the outside. Directrix. And again, this distance from here to here should be the absolute value of p, and so should this distance, the absolute value of p. So if you have a vertical parabola and your p-value is positive, our graph is going to open upward. And if your p-value is negative, your graph opens downward. And in that case, your focus would be below and your directrix would be above. And for our horizontal parabolas, if your p-value is positive, your focus or your graph will open to the right. And if your p-value is negative, your graph will open to the left. So for our focus, again, for a vertical parabola, it's either going to be above or below, depending on if your p-value is positive or negative. And for your horizontal parabola, your focus is either going to be to the right or left. So since it's above and below here, you can see that we can find it by adding or subtracting p to k. That means above or below. And then here, since it's going to be to the right or left, we add or subtract it from h. Okay? So again, above or below the vertex, to the left or right of the vertex. And then the directrix for a vertical parabola will always be a horizontal line, and it's either going to be above or below where your vertex is. So that's why it's going to be, again, plus or minus from k. And here it is a horizontal line, so remember it's y equals. And then for your horizontal, it's a vertical line, which is why it's x equals. And again, it's going to be to the left or right. So that's why we add or subtract it from h. And then the axis of symmetry for this is a vertical line, and our axis of symmetry is a horizontal line, and it always goes through your vertex. So these definitely make a lot more sense once we start trying a few examples with actual numbers. And for these, I always recommend that you kind of sketch just a really rough sketch of your graph so you can kind of visualize which way your graph is opening, where your focus and directrix will fall, and what type of line your directrix will be. Okay, so we're going to try these two together. We're going to look at the equation, we're going to find the vertex, focus, and directrix, and then we're going to sketch a graph. So for these, the first thing I like to do is determine if it's horizontal or vertical. So since x is being squared, I know that this is going to be a vertical parabola. And we can see by looking at the equation what our vertex is. Remember, it's always h, k. and it's opposite for both, so it's going to be at 3, -1. And to find the focus in Directrix, we do need to find the p-value. So remember, when it's in this standard form, this number out front is equal to 4p. So we just simply say 12 equals 4p. So that means that p is equal to 3. So we're going to use this p-value to help us find our focus in Directrix. So let's start by just doing a really rough sketch of where this would be. So it would be somewhere around here, 3, -1. And since our p-value is positive and it's vertical, we are going to be opening upward. So it's something like this. Okay, which means our focus is going to be 3 units above our vertex, and our directrix is going to be 3 units below. But again, this distance should be 3, and this distance should be 3. So I know if my vertex is at 3, -1, I can go up 3 by adding 3 to my y value. So my focus will be at 3, 2. And then I can find my directrix by taking my y value and subtracting 3. So it's a horizontal line at y equals -4. And this is what the graph looks like. Again, it's a really rough sketch because we're using it more to kind of visualize where the focus will fall and what type of line the directrix is. Okay, let's look at this next one together. So since y is the term being squared, this is going to be a horizontal parabola. And our vertex is going to be at -5, -2. So remember, this is always h. H is always grouped with x, k is always grouped with y, and they're both opposites. So it's somewhere around here, -5, -2, so just to estimate. And then here, our p-value is positive, so it's going to open to the right. So it looks something like this. And we do need to figure out what that p-value is. So let's do 4p is equal to 1/2. So in this case, our p-value is 1/8. So that means to find our focus, I would go 1/8 to the right. And to find the directrix, I would go 1/8 to the left. So this distance, again, here is 1/8, and this distance is also 1/8. So if I want to go 1/8 to the right, again, I'm going to add 1/8 to my y value here. So that gives me a focus at -39/8, -2. Again, I just take 1/8 and I add it to my x value to go to the right. And then I want to go to the left 1/8 to find where my directrix would fall. And this is a vertical line, so we say x equals -41/8. Again, that's just 1/8 to the left and then a vertical line through that. So again, when you're doing these problems, first decide if it's horizontal or vertical. Then decide what your vertex is, and then use your p-value, which again can be found by taking this term and setting it equal to 4p. Find your p-value and use that to help you place your focus and your directrix. All right, go ahead and pause your video and give these two a try on your own, and we'll check your answers in just a few seconds. All right, go ahead and check your work here. So for this first one, you have a horizontal parabola. Your vertex is at 4, 0, and this one is actually going to open to the left because your p-value is negative. So your p-value is -1, which means you go 1 unit to the left to find your focus, and then you go 1 unit to the right on the other side to find your directrix. And for part B, this is a vertical parabola because x is the term being squared. Our vertex is at -3, -7. And again, since our p-value is negative, our graph is going to open downwards. Our p-value is -1/2, so you go down 1/2 to find your focus, and then you'd go up 1/2 to find your directrix. So now we're going to try creating an equation given different pieces of information. For these, I really recommend that you sketch a graph, just a really rough sketch to help you visualize what's going on. So here we have a focus at -1, -1, Again, I'm just going to do a really, really rough sketch. So focus at -1, -1, and a directrix at x equals 5. So if this is my focus and this is my directrix, I know that the vertex must be exactly halfway in between my focus and directrix. The vertex is always exactly halfway in between. And if this is where my focus is, I know that my graph is going to open to the left. So I know two things here. I know that this is a horizontal parabola, and I know that P is negative. Okay, so now we can figure out where our vertex is, because again, it's going to be exactly halfway in between this at -1 and this at 5. So it should be 3 units from either way. So we can see that our vertex, which is right here, our vertex should be at 2, -1. So again, it should be exactly halfway in between where your directrix is and where your focus is. So that also means that we know that our p-value is this distance, so that p is -3, again, because it opens to the left. This distance is still the same. This distance is 3, but again, our p-value is negative because it's opening to the left. So now we know h, k, and we know p. So again, h is 2, k is -1, and p is -3. Now all we need to do is plug that into our standard equation. So for a horizontal parabola, it's x minus k squared equals 4p times, y minus k squared equals 4p times x minus h. So here we have y plus 1 squared equals -12 times x minus 2. And there you have it. So really all you need is h, k, and p, and then you can make your equation. Let's try another one together. So here we have a graph whose vertex is at 3, 5, so somewhere around here, and the directrix is at y equals 7. So if this is my vertex and this is my directrix, I know that my graph must be opening down. And I know that my parabola is vertical. So two things I know, vertical parabola, and again, I can see that my p-value is negative. So I can see that the distance from my directrix, which is at y equals 7, and this point, my vertex, is at 3, 5. So I know that this distance is 2. So I know that that means that my p-value is -2. So again, my focus would be somewhere down here. We don't even need to know what the focus is to make the equation. And I know that h is 3 and k is 5. And since it is a vertical parabola, the standard form is x minus h squared equals 4p times y minus k. So now we just plug in the variables we know. So x minus 3 squared equals -8 times y minus 5. There you have it. All right, at this time I'm going to ask you to pause the video and give this one a try on your own. All right, go ahead and check your work here. So based on where our focus and directrix are, and based on the fact that our directrix is horizontal, I can see that we have a vertical parabola and p is positive. And again, the vertex must be exactly halfway in between where the focus and the directrix are. So our vertex must be at 3, 1. So you can use those 3 values. The p-value is 1, because again, that's the distance from the vertex to the focus. And you plug it into your equation, and this is what you should get. Okay, I have one more for you to try on your own, so please pause the video and give it a go, and we'll check your answer in just a few minutes. All right, go ahead and check here. So based on the fact that your vertex and your focus are to the left and right of each other, you know this is going to be a horizontal parabola. Your focus is always inside your parabola, so it is going to open to the right, so it looks something like this. This distance is p, so in this case p is 3, and then we know h is -2 and k is -1, and then you just substitute those values into the vertical parabola standard equation. All right, the last thing we're going to do is we're going to convert an equation into that standard form, which will allow us to graph and find the focus in Directrix. So for this one, I can see that it's going to be a vertical parabola. So remember, our goal is to make it look like this. We want it to say y minus k squared equals 4p times x minus h. So we want this to look like this, which means we do need to complete the square for y. So that means the first thing I'm going to do is keep my y terms on the left, like this, and I'm going to move all of the other terms to the left, or to the other side of our equation. So now I'm going to complete the square for this trinomial. So you take your b value, you cut it in half, and you square it. So we get y squared plus 8y, and then we have plus 16. Again, 8 divided by 2 squared. On the right side, we have -2x minus 18. Make sure you add 16 to the other side of our equation as well. So this becomes y plus 4 squared equals -2x minus 2. But again, we want this to look like this, so we should factor out that -2. And we get -2 times x plus 1. So here we can see that our vertex is at -1, -4, so we can plot that. Again, really rough sketch. We can find our p value, so we can say 4p equals -2, so p is -1/2. So that means that our graph is going to open to the left, so it's going to look something like this. And then that means that our focus is going to be somewhere here, and that our directrix is going to be a vertical line here. So our focus is going to be to the left of our vertex, and it's going to be to the left by -1/2. So we're going to subtract 1/2 from our x value, so we have -3/2, -4. And then our directrix is going to be half a unit to the right of our vertex, and it's a vertical line, so it's going to be at x equals -1/2. All right, let's try one more together. So this one, since x is being squared, is going to be vertical, and we would like our equation to look like this. So again, we're going to need to complete the square for x. So we have x squared minus 4x. So I'm going to start by moving my other terms to the other side of the equation. Now we need to complete the square. So we take our b value, cut it in half, and square it. So that's 4. And we're going to also add 4 to the other side of our equation. Now we factor. So x minus 2 squared equals, so this becomes 4y minus 8. And then we do want to factor out that 4 to give us y minus 2. So we can see here that our vertex is at +2, +2. And then we can say, well, 4p is equal to 4, so our p value is 1. So this is going to open upward, something like this, which means that our focus is above and our directrix is a horizontal line below. So our focus is 1 unit above, so I add 1 to y, and our directrix is a horizontal line, so y equals, and it's 1 unit below, so I subtract 1 from our y value, so y equals 1. And there you have it. All right, so here's the last example. So one last time, please pause your video and give this one a try on your own. Okay, go ahead and check your work here. So our first goal is to make our equation look like this. It is a horizontal parabola. So you should get y minus 2 squared equals 12 times x minus 5. So our vertex is at 5, 2, and I can see that our p-value is 3. So since it's positive, it's opening to the right. And that means that our focus is 3 units to the right of our vertex. So notice I added 3 to the x value. And our directrix is a vertical line 3 units to the left. So I subtracted 3, and that's where our vertical line will fall. All right, that is all for today's video. Thank you so much for watching.